Hello and welcome to Computer Science. This is Liberty Basic Unit 1 and this is Lesson 4. We're going to talk about the for next looping today. The for next looping is very similar to in Scratch, the repeat loop. It tells you exactly how many times to repeat. In this case here is repeat 10 times. You would use for next as well if you know for sure that you're going to repeat 10 times. So obviously looping, we want to make a section of code run more than once. Often we know how many times to do this, or we can get the user to do it. This is known as a definite loop, and I'm going to highlight this somehow here. I'm going to draw a big red line underneath it. A definite loop is a loop that you know definitely how many times you're going to repeat it. In this case, 10 times. So let's just look at a simple counting program. We want the computer to count to 25. No real reason we would use this kind of thing. Maybe if you want to do something exactly 25 times, maybe you have 25 rounds in the game before you quit. We're just going to look at the counting part. Okay, so the general format for next is for some variable is equal to number 1 to number 2. And then there's the code that you want to repeat here. And then to end the loop, you go next, and then you use the variable name as well. So this executes the code part many times, and the number of times that it is actually it's number 2 minus number 1 plus 1. So it's way more complicated than Scratch. In Scratch, you just said repeat 10 times. This time, if you know, you're going to have to do a little bit of math to make sure you figure out exactly how many times it's going to loop. So it's going to be this number here, subtract this number here, plus 1. And you might think that sounds complicated, but I'll show you here it's not too bad. So if it's like for x equals 1 to 10, well, then that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 minus 1 plus 1, it goes 10 times. So it counts from 1 to 10 is all it really does. The nice thing about Liberty is in Scratch, you can only repeat a certain number of times. If you need the number to start at a bigger value, say for example here, if you need to count from 50 to 75 for some reason, you can say for x equals 50 to 75. Now you might think that's only 25 times, but that's not true, because if you count it, it would actually be 50, 51, 52, 53, 54, and so on, all the way up to 75. So it's actually 75 minus 50 plus 1, or 26 times. So a couple differences here. Scratch just allows to loop a number of times. Liberty allows the loop counter to start at any value, and it also allows you to count backwards as well. So it's a little more powerful. So if I want to repeat 10 times, I could have as well. I could have for count equals 10 to 20. This would actually do it 11 times, wouldn't it? It'd be 20 minus 10 plus 1, blah, 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 some kind of code in there. And then you end it off with next count. Notice the indentation here. So counting program, how high do you want me to count to? I want you to count to 50. I tell the computer, and it simply prints out the for next value. Let me show you how that would look. Pseudocode-wise, get the number to count to. We're going to call it max count. We're going to have a for loop. For loop equals 1 to max count. Then we're going to display the counter, or we're going to print it. Again, notice the indentation here. The display is inside the loop, so it's indented. And the for and the end of for loop are going to line up. And I notice that I actually do this in my pseudocode as well. Make your plan, your pseudocode, the same sort of look as your actual code is going to be. So here's the actual code. It's pretty straightforward. How high do you want me to count to? We're going to call that the variable max count. We're going to get the number to count to. That's my comment. For count equals 1 to max count, so I can use a variable in here. And then I print it. Again, notice the indentation. And then I end my loop by saying next count. And that simply means just add 1 to the value of count. Go to the next count value. Okay, so here's a practice assignment. Write a program that will find the sum of all numbers below that value. The maximum value that will work should be 10. If it's greater than 10, then the program will not work. So let's just see how this goes, what it looks like. Sample run, enter the number to find the sum to, and we're going to say maximum 10, just to make it simple. If I input a 5, my counter goes 5, 4, 3, 2, 1. I'm going to count backwards. And my sum, after the counter is 5, my sum is 5. I add 4 to that to get 9. I add 3 to get 12. I add 2 to get 14. And I add 1 to get 15. So the sum of the numbers 5, 4, 3, 2, 1 is equal to 15. That's my final sum right there. If I give a number bigger than 10, then say something like, hey, I said maximum 10, too bad, and the program ends. You might be wondering, how do I count backwards? You use a for loop like this. You go for count equals, you start with the first number that you want to start with, 4 to 1, and then you step minus 1, and the step minus 1 simply means when I go next count, my step value is minus 10. You could actually use this to count by 2s or 3s or 10s or 100s or whatever you want. So that's how you count backwards. You should have some idea of what an accumulator is. You've likely used them in Scratch. You might have had something like change player total by 1. An accumulator is simply a variable that adds a value to itself. So something like x equals x plus 1 means that you add 1 to the value of x and store it as x. Total equals total plus value is another example of an accumulator. And here the new value of total is total plus value. So suppose total was 100 and value was 150. Total will now become 250. Okay, so here is, you should pause probably now before you look at this. And unpause by now, hopefully. Give that a bit of a try. Hopefully you've tried that, and here's the solution. Here's the sum of the numbers program. So input, enter the number to find the sum to max count. If max count is bigger than 10, then say, hey, I said less than 10, too bad. Else, use the else here. I'm going to print count, comma sum. If you put a semicolon in there, you'll see what the comma does. The comma simply allows you to tab over to the next column step. I think it's about 8 columns over. For count is equal to max count to 1, step minus 1. And then I say something like sum equals sum plus count, print count, comma sum, and next count. If you didn't get that to work, pause the video for a moment, see if you can get that to work. Type in this code. I'll let you pause here at the video for a moment. Okay, so here's handout number 4. Write a program that has the computer pick a random number, and then it allows you to guess exactly 10 times. Each time it will tell you whether you are too high or too low. If you guess right, sorry, you're going to have to keep going until 10 guesses is up. Because we're going to use a for loop, we're going to guess exactly 10 times. We will solve this in a later lesson where we loop until we get it right. But for now, make the person guess 10 times. It should look something like this. You have 10 guesses to guess a number from 1 to 100. Use your random number generator that you've learned previously to this. What is your guess number 1? 76. No, that's too high. What is your guess number 2? 13. No, too low. What is your guess number 3? 27. Luckily, I got it right, but too bad I have to keep guessing. So then you would just keep entering 27 and the program would keep going, kind of thing. And again, we'll solve that in a later lesson, so don't worry about that. Here's the Scratch code that would do such a thing. It's actually quite easy in Scratch. There's a small little error in here. It's not quite right. I'll leave you to sort of figure out what that is. If you want to pause the video and just look at this. But that will give you some idea of how to do the program in Liberty Basic. As a bonus hand-in, if you're way ahead, if you want to try write a program to print the Fibonacci sequence, the user will enter a value n, maximum of 25 will say, and the program will print the first n numbers in the Fibonacci sequence. I'll let you Google to see what the Fibonacci sequence is. It's a bit of a challenging program, but if you're way ahead, you've likely got time to give this a try. Here's a sample run for the Fibonacci sequence. Okay, good luck with that, and I'll see you in the next lesson.